Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 143. Day number 143. We are in the process of solving word problem from day number 101 through 200. Today is our 43rd day. Yesterday we learned how to write consecutive numbers in the language of algebra. How do we write consecutive numbers if we are told that certain number has to be the least one, or certain number has to be the greatest one, or the certain number has to be the one in the middle. And we learned that yesterday. Today we're going to learn how to write an even number. For example, if I tell you that I have some number, write a number in general, any number at all in the language of algebra would be n, or x, or k, or m. This is any number, any integer, positive, negative, whatever. If I say I have some integer and 3 more than that is 5. I have some integer and 3 more than that equals 5. I have some number and 3 more than that, which means 3 plus that amount equals 5. What is that number? Well, that number must be 2. I have some number which is 2, 3 more than that equals 5. You see, I have some number. That some number has to be represented by some variable to set up an equation. I could have written n, we could have written x. Traditionally we write x for the unknown. I have some number x. And 3 more than that equals 5. Or we could have represented that some number as k, or we could have represented it a, or we could have represented it with alpha, or we could have represented it with m. We could have represented it with anything. That's it. But what if I tell you that I have some even number? And 4 more than that is 10. How do you write an equation for that? How do you write some even number? An even number. We cannot just say x. That x may not necessarily be even, because what if the value of the x turns out to be 5? 5 is not even. It has to be represented in such a way that regardless of what the value of the x is, positive, negative, even or odd, the quantity that you're claiming is even has to be even. And how do you make sure that that happens? An even number in the language of algebra is represented as 2 times some variable. 2 times some variables. 2 times x, or 2 times m, or 2 times y, or 2 times k. It has to be 2 times some. Why? Because 2 times some variable. Why? Because we want to make sure that the quantity 2 times this variable that you're saying, 2 times x, is in fact even. Is in fact even, then I was about to say even when, but that's going to be confused. Is in fact even regardless of what x is. Regardless of what x is. So here, this is an even number. This is how you write an even number. An even number, one more time. An even number in the language of algebra is to be represented as 2 times some variable. 2 times some variable. 2 times some variable would be, as I said here, 2 times x. So that this x can be even, this x can be odd. It doesn't matter. If this x happens to be odd, then 2 times 3 is still even. If this x happens to be even, then of course it is even. It doesn't matter. It doesn't matter if this x is positive or negative, because if this x happens to be negative, then and if this x happens to be negative 3, you see, there are two problems with this thing. This x here, this is your x. There are two problems with it. First is that this x itself is not even. X is 3. As a matter of fact, negative 3. But it doesn't matter, because by the time we multiply it by 2, by putting a 2 in front of it, we are forcing it to turn out to be this quantity 2 times x. We are forcing it to make sure that it is in fact always even, regardless of whether this variable x is even or odd. That's all. I'm going to say it one more time. In the language of algebra, an even number has to be represented as 2 times some variable. So that if that variable turns out to be odd, it still does not cause us any problem, because odd numbers times 2, which is an even number, an even number times odd number will still turn out to be an even number. If this x turns out to be 5, 5 times 2 is 10, which is an even number. If this x turns out to be 13, 13 times 2 is 26, it's still an even number. That's all. So here's the question for today. Now that we understand that concept, here's the question for today. I need to erase everything. I need the room, so I need to erase everything. Actually, I'm going to do the problem here. I'm not going to erase any of this thing here. I'm just going to read everything one more time. It says an even number in the language of algebra is represented as 2 times some number, 2 times some variable. 2 times some variable. The question is why? Why? Because we want to make sure that the quantity, in case you have trouble reading my handwriting, we want to make sure that the quantity 2 times x is in fact, this says in fact, this is in fact even. 2 times this quantity is in fact even, regardless of what x is. Regardless of what x is. What I meant by that is odd or even. It doesn't matter what x is. X is just some number, and 2 times some number, whatever that number is, even or odd, 2 times that quantity will always be even, and that's how you represent an even number in the language of algebra. Enough said. Let's do the question for today. The question for today is very simple. The question is this. What is the next even number after 2n? So 2n is an even number. We know that for a fact, because it doesn't matter what n is. Even if n happens to be 3, 3 times 2 is 6, it's an even number. The question is, what is the next even number after that? Well, if the 6 is the even number, the next one is going to be 8. How do we get 8? By adding 2 to it. If n happens to be 5, watch here. If n happens to be 5, 2 times 5 is 10. So this quantity is 10. The question is, what is the next even number? Well, next even number after 10 is 12. How do we find 12? By adding 2 to this quantity. And that's what we're going to do. Answer to this question is very straightforward, very simple. The answer is, what is the next even number after 2n? It is your 2n that you have plus 2 more. That's it. That's it. That's the answer. Except in the correct answer choices, had it been a multiple choice questions, if you were taking SAT, GRE or GMAT, and if you have to choose one of the answer choices among the 5, the answer may not be stated like that. It has to be simplified. It has to be put in a more elegant way. So here's your first term. Here's the first term. Here's the second term. Do we find anything common in them? We find 2 common. 2 is the common factor. This is 2 times n, and this is 2 times 1. 2 times n and 2 times 1. 2 is common. Let's take out 2 common. And here we're left, after we take out 2, we're left with n. We're left with n. And here, once we take out the 2 common factor, we are left with 1. So this is how we write the answer. And of course, this does gives you 2 times n is 2n right here, and 2 times 1 is your 2. So 2 times n is 2n, which was our original even number, and then 2 times 1 is 2, 2 more than that. So that's the next even number. That is the next even number. Similarly, let's continue here. So we learned today how to write an even number in the language of algebra. And if you have an even number of 2x, what's going to be the next one? 2x plus 2. 2x plus 2. 2x plus 2. I'm going to erase all this thing because there's a limit to how long I can keep it on the blackboard. I need the room. So here is an even number. 2 times z. That's an even number. What's the next even number after that? The one after that is going to be 2z plus 2. What is the one before that? One before that is going to be 2 less. It's going to be 2z minus 2. And of course we're going to represent that as, we're going to take out 2 common from here. So it's z plus 1, we already saw that. And this is going to be take out 2 common again. So we are left with 2 times z minus 1. You see? 2 times z is 2z, and 2 times negative 1 is your negative 2. Again, 2 times z is 2z, and 2 times positive 1 is your positive 2. Here's the next question. Not the next question rather, but the next statement. Similarly, okay, pay attention. Similarly, an odd number in the language of algebra is represented as how do you suppose? As, well, if you ask me for an odd number in the language of algebra would be any old even number. And how do you write any old even number in algebra? Well, we just learned it. Any old even number is 2 times x. So you write your any old even number, this is any old even number, plus 1 more than that. So now it's odd. So if x happens to be, watch here, if x happens to be 2, 2 times 2 is 4, 4 plus 1 is 5. If x happens to be 3, we have no control over what x is. X could be anything. X comes out to be 3, 3 times 2 is 6, 6 plus 1 is 7. You see? This was 5. So starting out with any old even number, which is 2 times some variable, and then adding 1 to it ensures us that the next one has to be odd. If the one that we have in our hand is even, then the one that follows immediately after that would have to be odd. It's just one more. You understand? That's all. Again, this could be positive or negative, it could be even or odd, it could be anything. That's all I have for today. There was no actual problem to solve for today. We're just learning how to write even number and odd numbers in the language of algebra. Yesterday, as I said, we learned how to write consecutive numbers. Today we are learning how to write even and odd numbers. Okay? I will see you tomorrow on day number 144. Bye now.